Hello everyone, welcome back to another video. Today we will be solving the fifth question of the Blind 75 series. The name of the question is maximum subarray. Let's go to the question. So guys, this is the question and you can see this is a popular question. This has been asked a lot of times in top companies. The problem statement is you are given an integer array nums and you need to find the subarray with the largest sum and you have to return its sum. Before starting with the solution, let's first understand what this subarray actually is. You can see here the definition of subarray is given. A subarray is a contiguous non-empty sequence of elements within an array. Let's understand this with the help of an example. Let's suppose we are given an array which has elements as 1, 2, 3, 4, 5. So if this is an array, the subarrays in this can be 1, 1, 2, 1, 2, 3, 3, 4, 3, 4, 5, 2, 3, 4, 5. So any part, if it is a contiguous, that part will be considered as a subarray of that array. Even if there is a single element, the single element will always be considered as a subarray. So which part will not be the subarray? Any part which is not contiguous. For example, this 1, 3 is not contiguous because we have skipped the element 2 over here. So this will not be considered as a subarray because this is not a contiguous part. Similarly, 2, 3, 5 is also not a subarray because we have skipped the element 4 over here. So as long as the part is contiguous and non-empty, we will consider that part of an array as a subarray. Okay guys, now we have understood what subarray actually is. Let's proceed to the solution of this question. So the question says that you will be given an array as an input, and in that array, you have to find the sum of that subarray, which is giving you the maximum sum. You know, in this array there will be multiple subarray, and out of all those subarrays, you have to choose one which is giving the maximum sum, and you need to return the sum of that subarray. Okay, so the very first approach that comes to our mind while we go for the solution of this question is as we need to deal with as we need to deal with the subarrays and we need to find the subarray which is giving me the maximum sum. What I can do is I can check for all the subarrays that exist in this array and I will find the sum of all the subarrays in this array, and out of all the sums whichever will be the maximum, I will simply return that. Now the question comes, how we can check all the subarrays in this given array. So it is very simple guys. For example, let's suppose you are given an array as this. So let's suppose this is the given array, and in this array you need to find all the subarrays. So how you can do it? It is very simple. So if you want all the subarrays which are starting with -2, so what you can do, initially you can take -2 as a subarray, and after that you just have to increase the size till you reach to the end of this array. Initially, the subarray will be -2, then the next subarray will be -2, 1. After that, the subarray will be -2, 1, -3, and so on till we reach to the last index. Similarly, if we want any subarray which is starting with 1, so what we can do is initially we can take single 1. After that, we have to just increase its size till we reach till the end. So it will be like 1 minus 3, then 1 minus 3, 4. So in this way, we will be able to generate all the subarrays in this given array. So for doing that, we can use two nested loops. The first loop will go from 0 to n minus 1, and the second loop will go from I to n minus 1. So you might be having doubt why this second loop is going from I to n minus 1. So guys, as you have seen here, so if we want any subarray which is starting from this particular index, for example, I'm at index 4, I'm at this element 4, and I want all the subarrays which are starting with this from here, from 4 to end. So what you can do is initially you will just take this element 4, and after that you will just keep on increasing its size. After that you will take 4 minus 1, 4 minus 1, 2. So till you reach the end, then you have to just increase the size. So that is why the first loop is starting from 0 to n minus 1. We are going from here to here. And for every I, we are going from I to n minus 1 to check all the possible subarrays that are starting from that particular point in the given array. Okay, so as you are, as you are going through these sub arrays, what you can do is you can declare a variable which will be initially initialized at 0. So that variable name is current sum. So this variable will be initially declared as a 0. And as you move ahead in this array, as you are considering the other sub arrays, what you can do is you can simply add that element to your current sum to get the sum of that particular part of the sub array. And at last, when you will have considered all the subarrays, your maximum sum that you have got will be stored in this variable named as answer. So in this way, by checking all the subarrays in this given array and finding their sum, you can get the answer for the maximum sum subarray in this given array. Okay, so the time complexity for this solution will be near about big of n square, because we are using two nested loops here. And as we are not using any extra space over here, the space complexity here will be big of 1. Okay. But guys, if we see the constants over here in this question, so the constants are the length of this array can be up to 10 to the power 5. Okay, so as the constants are pretty large, we cannot go with the solution of big O of n square. It will give us TLE. Uh, if the constants are up to 10 to the power 5, the maximum complexity solution that we can go for is n log n. We cannot go beyond the complexity of n log n. So we have to think of a solution that solves this given problem in the time complexity of n or n log n. So it should be less than n log n. Okay. So to solve this problem, we have a famous algorithm named as the cadence algorithm. So this algorithm is especially designed to solve this problem, the maximum subarray sum. Okay, so guys, at first let's first understand what all are the steps of this algorithm. And once you have the sequence of steps in your mind, then we will understand what is the reason behind each and every step in this algorithm. Okay, so initially you have to declare two variables, maximum sum and current sum. So this maximum sum will store our final answer, that is it will store the maximum sum that I have got in the array till now, and this current sum will store the sum of the subarray that I'm currently checking or that I'm currently considering in the given array. The algorithm is quite straightforward. You have to iterate through the elements of the array once, and as you iterate through the elements, you have to add that element to the current sum. So as you will move ahead in the array, you will keep on adding those elements to the current sum. And the second step is you will simply check if your maximum sum that you have got till now, if it is still lesser than the current sum. So you will simply update the maximum sum to the current sum. And at last, you will check if my current sum has become less than 0 or it has become negative. So I will again set the current sum to 0. And at last, when this iteration is over, when this loop will be over, the maximum sum will be stored in the variable named as max sum, and I will simply return that. Guys, if you are not able to understand the logic of these steps, it's okay. I will tell you the logic at the end, but let's first understand these steps. Let's keep these steps in mind, and just we will do just dry run using these steps in the given array. And after that, I will be telling you what is the reason behind each and every step in the algorithm. Okay, so let's consider the example that is given over here. So we have taken this example over here. This is the same example. So as the algorithm says, initially you have to declare two variables named as maxsum and cursum. So this maxsum will be storing the maximum sum of the subarray that I have got till now, and this current sum will be storing the sum of the subarray that I am currently checking for or that I am currently considering in this given array. The max sum will be initially initialized as int min, because this is the least possible value of the maximum sum. So anytime if we get the better sum than this, I will simply update that sum to the to that particular sum which is better than this sum. So that is why initially it is initialized as int min. The second variable is current sum. So it will be declared as 0 initially. And as I will be considering the elements of an array, I will simply add those elements in this current sum to get sum of that particular part of the subarray. Okay. So let's do the dry run of this algorithm. So we will be having two variables, current sum and maximum sum, and their values will be changed as we move ahead in this given array. So when we will go to the first element here is -2. So I will simply add this -2 to the current sum. So the current sum will become -2. Then I will check if my maximum sum is lesser than the current sum. And yes, it is, because initially it was int min. So the int min is obviously lesser than this -2. So I will update this current sum to -2. Okay. So the third step was, if my current sum is lesser than 0 or if my current sum is negative, so I have to set current sum again to 0. So here you can see that the current sum has become negative. So I will again set this current sum to 0 over here. Okay. Then we will move to the next element, which is 1. So if I will add 1 to this current sum, so the overall sum will become 1. Then I will again check if my maximum sum that I have got till now is lesser than the current sum that I have got. Yes, it is lesser. So I will set this maximum sum to 1. Okay. Then we'll move to the next element. So the sum will be 1 minus 3, that is -2. Again, I will check if my maximum sum is lesser than the sum that I have got. uh, it is not, because the earlier value of this was 1 and now the current sum has become -2, so I will not be considering this value in my maximum sum. So guys, you can again see that this value has become negative. So I will again set this value to 0 before moving to the next element. Okay, so now we will move to the next element, which is 4. So if I will add this 4 over here, so the overall sum, the current sum will become 4. And I will again check if this sum is lesser than the maximum sum that I have got. And it is lesser because maximum sum was 1 initially. So I will again set this maximum sum to 4. Then we will move to the next element, which is -1. So the sum will be 4 minus 1, that is 3. I will check if it is more than the maximum sum that I have got till now. It is not. So I will simply move to the next element. So I will move here. So the sum, I will move here. The sum will be 3 plus 2, that is 5. And I will check if this sum is greater than the sum that I have got till now. Yes, it is greater. So I will set the value of maximum sum to 5. Then we will move to the next element, which is 1. So the current sum will become 6. And I will again check if my maximum sum is uh, lesser than the current sum that I have got. And yes, it is lesser. So I will set the value of this maximum sum to 6. Okay. So then we will move to the next element, which is -5. So this time the sum will be the current sum will be 6 minus 5, so it will become 1. So I will check if this value 1 is greater than the maximum sum that I have got till now. So it is not. So I will keep this value of maximum sum as 6 only. I will not change this value to 1. And again, this value is not negative, so I will keep this value as 1 only. Then finally I will move to the last element, which is 4. So if I add 4 to this, the maximum sum that I will get will be 5. Again, I will check if it is lesser than if it is greater than the sum that I have got till now. So it is not, so I will keep the value of maximum sum as 6 only. I will not update it to 5. Okay. So this is a sequence of steps which you have to go through in order to find the maximum sum subarray in this given array. Now we will understand the logic behind each step, but before that, let's first analyze the time complexity of this algorithm. So as we are going through the elements of array just once, so the time complexity will be big O of n, where n is the length of this array and the space complexity of this algorithm will be big O of 1 because we are not using any extra space over here. Now let's understand the reason behind performing each step. Okay, so initially I have declared two variables, max sum and current sum. The variable max sum is initialized to int min because as I have to return an integer value, you can see over here. So this int min is the least possible value of an integer. As you can see in the second step of this algorithm, every time I am getting a better sum which I have got than the sum which I have got previously, I am simply updating that maximum sum to that particular value. So that is why initially I have initialized the minimum possible value so that every time I get a better value or a greater value, I will just set this variable maximum sum to that value, and this current sum is to store the value of that particular subarray which I am currently considering. So initially it is declared at 0, and the all all the values of the subarrays will keep on adding to this value as I iterate in the array. So first two steps are quite like straightforward. This current sum will be adding the elements of array to itself as I iterate in the array, and this maximums the second step is again quite straightforward, that if my maximum sum is lesser than the current sum, so I will simply set the maximum sum to current sum. So the third step is the most important step in this algorithm, and this is the main intuition behind the working of this algorithm. If current sum is lesser than 0, we are setting the current sum to 0 again. So let's understand why we are doing so. So to understand that, uh, you let's assume that initially the value of current sum was -2. So what current sum was actually storing? It was storing the sum of a particular part of an array. For example, so as you can see here, the value of current sum was -2. Okay, so if the value is -2, doesn't matter what value is after it, the value after it can be plus positive or a negative. So if I will be adding this particular part, the sum of this particular part in the overall sum, as this sum is negative, this will decrease the overall value of that subarray which I am currently considering, because this 5 minus 2 will be 3, which is lesser than the value 5. So it would have been better if I would have just considered this 5 value instead of considering this whole value -2 plus 5, because it is negative, uh, it is decreasing the overall sum. Again, you can see over here, initially the current sum was -2, and if I will add this -2 to any negative value, that is -5, which is -7. So -7 is actually lesser than -5. So it would have been better if I would have just considered value -5 instead of considering this whole negative array. So the reason is, if any part of an array is giving me the negative sum, so that part will never help me to get the maximum sum. That is why I'm just discarding that part. As you can see over here, uh, when I am considering this subarray, like initially I considered this subarray that is -2 only. So I saw that the overall sum of this particular part is negative. So there is no point of to uh, adding this part further to get the maximum sum, because as this part is negative, if I will add this part to any part further, so this will only decrease the overall sum. I need to maximize the sum. So there is no point of keeping this part. That is why I am simply discarding this part. That is why I am again setting the value of current sum to 0, so that when I just go to the next part, I will be again considering this element as the first element of a subarray. So setting value to 0 just signifies that I am discarding this part, because this part is giving me the negative sum. So it will not be beneficial for me to get the maximum sum. That is why I am simply discarding this part. Again, you can see over here, when I was considering this part, this 1 minus 3 is minus 2. Again, the sum of this part is negative. So if I would have considered this part in the subarray which has got me the maximum sum. So this was the subarray which got me the maximum sum. This 4 minus 1, 2, 1. So the overall sum of this particular part from here to here is 6. So had I added this particular part to this subarray, so my overall sum would have become 6 minus 2, that is 4. So adding this part is not beneficial for me because the sum of this part is negative. So it is only decreasing the overall sum of this whole subarray. So that is why whenever we are getting a negative sum, we are simply discarding that subarray, because uh, that subarray will not be beneficial for me to get the maximum answer. So this is the reason behind making the current sum to 0 every time when the current sum is becoming negative. I hope guys now you have understood the reason behind each and every step that we are performing over here. Now let's just code the solution for this particular problem. Initially, we have to declare two variables named as maximum sum, which will be initialized to int min. The another variable will be current sum, which will be initialized to 0. Then I have to simply iterate through elements of this array. The first step was I will add this current element it to the current sum. Second step was I will check if my maximum sum is lesser than the current sum. So in this case, I will set the maximum sum to current sum. The last step is I will just check if my current sum has become negative. So I will set current sum to 0 again. So when finally the iteration is over, the maximum sum of the subarray will be stored in this variable maxsum. So I will just return this. Let's run this. Okay guys, this is passing the sample test cases. Let's submit this solution and it gets accepted. So this is all for today's video. We will meet in the next video. Till then, bye bye.